Hi students, today I am going to explain criteria for rejection of data. So what criteria we use when we are analyzing some data will not be useful for us and or which is not fitting for our values, then we have to reject that data. So how we will do this? So sometimes analytical data appears as a value which is not fitting in the set, looks as wide difference from the rest of the values. So whatever are the values, it looks like a wide difference from the our values. So in that cases we use the rejection of data. For this, so many rules are there, but the very recommended and widely used rules are 4D rule by using a range or Q-test. Some criteria are there for rejection of data of outlier. So what are the 4D rule and Q-test? So let's explain what is 4D rule. So let me explain the 4D rule. So what is 4D rule? This test is based on the fact that 4 times the average deviation, which is an estimate of psi, which lies in the probability distribution curve at a confidence level of 99.8%, that a value of measurement lies within the limit. So what is 4D rule? So it is telling that we have to take the average deviation and we have to multiply it with 4. So 4 times the average deviation, which will give an estimate of the value which we have to emit. The significant figure we can take and we can remove the data which we don't want insignificant. Yes, no. So for this rejection of outlier, so in this we just take average deviation and multiply it with 4, so that it will be in a confidence level of 99.8%. So the value of the measurement lies within this limit and it will have this probability distribution curve at 99.8% confidence level. So to apply this rule, at least we want 4 observations. Excluding the outlier, not including the outlier, excluding the outlier, at least we want 4 observations. So we can prefer 10 to 30 observations. If 10 to 30 observations are there, it will be good to do this method. So what is the procedure of 4D rule? Let's see. First, omit the doubtful value and find arithmetic mean of rest. So first we have to omit. Omit means remove. Remove the doubtful value, whatever is there, and we have to find the arithmetic mean of the rest. We know how to do the arithmetic mean. Mean is sum of the values by number of values, right? So we will get the average deviation. So find out the average deviation of the rest of the values after removing the doubtful value, and it is nothing but D. It is nothing but D, and we have to multiply it with 4. So we will get 4 into D value. So after that we have to find the difference between the doubtful value and the mean calculated value. So whatever is the mean calculated value, we calculated mean, arithmetic mean. Is no, from this the doubtful or suspected value, we can say suspected or doubtful, both are same. XS is the suspected value minus mean we calculated. This both we have to do the difference. Then if the difference, that is nothing but Z, if it is more than 4D, here we calculated 4D, right? If it is more than 4D, then the suspected value should be rejected. If it is less than or equal to 4D, then we can retain it. Like this, we can do it very simply, very easy. First, remove the doubtful value and find the arithmetic mean of the rest. After that, we will find D value. So 4 times of D. Then we have to do the difference between the suspected value and the mean value. And we see the difference is greater than 4D or less than 4D. If it is greater than, reject. If it is less than or equal, retain. So this is the simple process. Then Q-test. So it is also a very simple method and it is widely used for rejection of suspected value in a set of 3 to 10 results. If 3 to 10 results are there, then we can do it. What is Q here? It is nothing but rejection coefficient. What it is? Rejection coefficient. What is rejection coefficient? Is the ratio of divergence of suspected value from its nearest neighbor. So how much divergent it is, the suspected value, how much different it is from the nearest neighbor to the range of set of measured values. So all the set of measured values, whatever is there, what is its range? So this is Q. Then we'll get a quotient, that is nothing but rejection quotient. What are the steps we'll see? First we have to arrange the observations either in a decreasing or increasing order. The lowest or highest or both may be doubtful. So we can take even the highest value or the lowest value, or both we can consider it as doubtful. Then calculate the range. How we will calculate the range? Highest value minus lowest value. So the range is nothing but highest value minus lowest value. Then find the difference between suspected value and its nearest neighbor. So whatever, when we arrange in a increasing or decreasing order, we will see the some value which is suspected value, what we have to remove. Just find the difference between this and the nearest neighbor. We'll get Y. And we also got R, range. Yes, no, both we got. Now we can calculate Q easily. So calculate Q is equal to Y by R. So Q calculated, that Q is nothing but Q calculated. But we also have one more Q, that is from the table. So they gave the observations for us. 3 to 10 observations I told. We arrange it in increasing or decreasing order and we write in a tabular form. That is nothing but Q tabular form. So if the Q calculated value is greater than Q tabular form, it is rejected. So if the lowest value is rejected, we are rejecting the lowest value, then our range R dash for remaining value is calculated. We just remove the lowest value and again we will calculate the range. What is range? Highest value minus the lowest value after removing the lowest value. Yes, no. And if the lowest value is not rejected, the same range will be there and we can continue this process repeatedly to obtain a value, suspected value, which we have to remove. So this is the process and it is a very easy and important process and widely used process.